go then. So, things that you have to do for next week, for the weekend. Hopefully Friday night will relax a little bit. People are stressed out. I acknowledge that. I'm just joking about your Friday night plans here. But you do need to peer review the 2 papers this week, right? So everybody should have received a peer review, 2 papers to peer review. A few of you, their names and scenarios. If you can't find them, let us know, but you should be able to find them on Canvas. And those are due Wednesday, and you'll submit those directly back into Canvas. And I'll talk about that. And then there's more to read about chaos in the textbook. Who likes the textbook? You like the textbook? It's a textbook that's almost obsolete. At least in the field.
Very direct.
Yeah. And it's graphic. It's a support. It's a support for what you need to know in the lecture. Again, this is the lecture materials that are on the slides, they're published, are the things that you're required to know. The textbook gives you background for that. So taking good notes from lectures, even those resources gives you a sense of out of all the incredible amount of material that we're flashing through here, that's the stuff you need to know. So, but do use it as a resource. I think it helps a little bit to back in. So today we're going to flash through the Actinopterygii to the Actinopterygii. I want to start with, so we ended up with the coelacanth. Too much time watching videos on coelacanth, but I find it interesting. And it's what's going on with the slide up there in the upper left-hand corner, but it's the other group. That's what's going on. Okay, sorry. So the other Actinopterygii fish is the order Gypnol, which you were talking about. There's 2 or 3 families. There's a total of 6 species. Of course, they're lungfish that have lungs for air breathing, with the exception of the Australian lungfish. Most are obligate to air breathing. The Australian lungfish has the capacity to do both. And that's an exception. They're jointed fins, they're very much homologous skewers, just like the coelacanth. You know, the coelacanth gets all the love and glory because it's like this ancient fossil fish, but really, the kind of fascinating under some fish here are the lungfish. Really are the sister fish to all of the other tetrapods. They have cycloid scales. That's wrong. They don't have cycloid scales. There are no scales. They're scaleless as far as I know. They have massive tooth plates, and they appeared a long time ago back in Proto-Devonian. They're mostly freshwater species today, although they were very much diversified in the olden days, and they feed on the bottom. Most of them are fairly endangered. Surprising they've lasted so long. But maybe it couldn't be. It's at the start with it quite a lot. An interesting thing is an interesting species is the West African lungfish. Again, an obligate air breather, and they have this species, probably because of these specialized adaptations, they have the capacity to burrow into the mud and excavate during the dry period, and they form this like mucus cocoon which dries into this leathery case, and then they slowly metabolize their own body over the period there. They're not doing much. They're just in this place of deep excavation or hibernation in the summertime, in the dry season. And then when it rains, they reemerge and they slither out of their cocoon. And this is actually inside this. This is not a rock; it's a mud case. And this is the fish that's inside this mucus cocoon. Very interesting adaptation. And this has worked well for the species. They in particular are of least concern. And it's probably an adaptation that dates from the I guess it was called the Carboniferous, during Pangea, when when droughts became widespread across the superclimate. And this became an adaptation both for fish, both being able to breathe air and to be able to excavate for long periods of time. And this is the video that I'm not going to show you. Oh, it might just play itself. But it's going to take really great. Right. And I'm always sad that it feels. This shows a lung that's walking. They came out a few years ago, and now everything's just frozen up into the system. But you can view it in your own time. Let's see if I can get it. Slide. Oh, there it is. You can watch the. There it goes. So you have your coelacanths, slamming around at 750 meters, but then you have your lungfish that are actually walking, trying to walk like your ancestors did. So that's the Actinopterygii, the coelacanths, the dipnoid tetramorpha, the dipnoid, the order, and then the tetrapods, which is all your other classes in wildlife biology. And so I want to jump into the ray fin fishes now at last. And the ray fin fishes, again, an ancient fish, has its roots deep in the Devonian in terms of, or actually the Proto-Devonian in terms of adaptation, but we see that, for a long time they were, they didn't really have a lot of success until we entered the Mesozoic period. The post-Permian extinction led to this real great agent of modern bony fishes, the teleosteans, and then we have these modern representatives that have similar roots as ray fin fishes. And those include the sturgeon and the gar and the shears that I'm going to talk about today. We'll put that in the Oh, so I want to start with Cladistia. These are the shears, they're the most ancestral. And I want to talk about innovations in this group so that as we go through, because the group is this is an important lecture today because the group moves through these radical innovations that led us from these sort of early ancestral fish to the modern fishes that we think about as being more derived. And the first innovation, they're called ray fin fishes, and they have these flexible fin rays that I've talked about before. And the key things about them is that these fins are flexible. The rays are flexible. They can collapse and expand, and they're supported by rays. They're not like joint rays like in the Actinopterygii, but they have this structure they have a muscular structure. It's not directly attached to the skeleton, but within the fish, so that they can move these rays. They can erect the dorsal. They can collapse the dorsal. They can move their pectoral and pelvic fins to maneuver. And then they have multiple sets of fins that allow them, and this ability to control them that allows them to take advantage of these different hydrodynamic conditions that makes them so able to navigate and to radiate into the modern environment. Actinopterygii innovation 2 are scales, and in this case, for the early the sort of more ancestral actinopterygii fishes that we're talking about today, we're looking mostly at ganoid scales, which are those tough scales made of the material ganoin. They're interlocking like puzzle pieces, and they're not overlapping. And with the teleostean fishes, which are just gonna, not really make it to today, but hopefully by Monday, that's where the cycloid scales are introduced. These are these light overlapping scales that allow for flexibility, and they're smooth. And then the Actinopterygii, which is kind of the beamer of the teleostean fishes, we have the introduction of these phenoid scales, which are also light and overlapping, but they're irregular in shape, which provides them a variety of opportunities to cope with their environment. And then the other Actinopterygii innovation, I'm not sure that this is really it. It's not an innovation. Ovipaired egg laying. These ancestral fishes often, including the sharks, many of them were oviviviparous. So they were holding eggs inside the body cavity and then giving live birth in a lot of cases, including coelacanths. The Actinopterygians are starting to lose this capacity. They're the only live bears, there's just two groups that I can think of that are live bears. The celids, which include guppies and mosquito fish, and the ambiotocids, which are the surf perches. Off the coast of California, there's a huge array of surf perches, and you have the tube perch in inland waters, all live bears. But most of the teleosteans have discarded this burden of doing live births, and instead they lay eggs. And I think that the reason that this became more adaptive per se is because it requires a predictable environment, and Earth has changed itself since the development. So there is a more predictable place to lay eggs, deposit them, and leave them. Although some fish have adapted capacity to lay and to make nests, to care for their brood in an effort to maximize production, while still lightening the load of the animal, which makes it more flexible and able to navigate its environment without being eaten, basically. It's a lighter, faster fish without having to carry babies around. So those are the first of the Actinopterygii innovations. Let's talk about how they're applied in the Polypteriformes, the Bashirs. Again, this is the sister group to all the other ray-fin fishes. And so they're the most ancestral, and they have these new fin rays and the ganoid scales. They have lungs and gills, which is interesting. They still retain the heterocercal tail, but you can't really see it. But it's much more symmetrical now. The way that the rays are coming up that provide a measure of symmetricality, which allows them a little more flexibility and power in their thrust when they're moving, when they need to move. These fishes still are retaining a cartilage skeleton, and they still have the fused premaxilla. So this biting jaw, in which the this biting jaw, where the maxilla, the upper jaw, is fused to the skull. And when in order to make their gait large enough, they have a hinge at the back of the skull, which allows the head to move back, which is a very primitive characteristic we've seen on all the fishes. So the next group are the Chondrosteae, which include the sturgeons. And these have a more mixed palate of ancestral and derived characteristics. The main innovation for this group is the swim bladder. Swim bladders are derived from lungs. Embryologically, they still develop as an outpocketing of the gut, which is exactly evolutionary. This is, ontogeny capitulating phylogeny. Wait, phylogeny recapitulating ontogeny. That is the development and evolutionarily of the team in embryological development. An interesting thing is that this is the derivation of both lungs and swim bladders. No fishes that we know of have both. And you may recall, I flew through this at the end of the lecture. There are two types of swim bladders. This is a good piece of information to know. There's the physoclistic and there's the physostomatic. And can anyone recall the difference between them? The hint is in the name, physostomatic. Yes?
One is filled with characteristic change.
Well, it's not. It has a gas organ on it, and the gas organ allows gases to fill the swim bladder using a current exchange process on the vessels coming into the swim bladder. So good. This one is essentially it's using gas exchange from the blood to fill and also to deplete the air bladder. And then the physostomatic, yeah, they just swallow air. They just swallow air, which in some ways it's mostly shallow water. Which can create weird problems if you catch a deep sea fish. The swim bladder expands because they expand, and the swim bladder comes out of the mouth. Traumatizes the fish and often kills it. For deep sea fishermen that want to be catch and release, they have this technique. I don't know about it. So there's a way to weight the fish, catch the fish, and take a picture of it with this giant phallic swim bladder coming out of its mouth. Or fish when you put a weight on it, It sends the fish back down, it compresses the swim bladder and releases the fish somehow. And I don't know. I don't know what to say about that one. So anyway, let's move on. What people will do for roasted. So there's two families that you should be familiar with. There's the sturgeon and also the paddlefish. The sturgeon is class Actinopterygii. They have the size of swim bladder. And these, the chondrostii, both these groups have a cartilaginous skeleton as well. In this case, it's notable that the cartilaginous skeleton is derived, not ancestral. So their forebears had an ossified skeleton. They lost it. They lost it in exchange for the heavy ganoid scutes that cover the body that they have for protection. And so it became a compromise. It lightened them up so they could manipulate. They could move essentially more into it. And they still have a heterosexual tail. In Moyle and Check, which is the other book that I refer to once in a while, they say that it's sort of a garbage thing. Fisheries problem. It's a garbage thing. It's just basically means I don't really hold together. But suffice it to say that it's a group and so the scutes, 5 rows of scutes is typical. They have these sensory barbels on their mouth, which is the mouth is on the underside. It's on the underside of the fishes because they're mostly benthic feeders and small invertebrates, clams, and bugs. They're mostly found in the northern hemisphere, and they tend to be freshwater and anadromous. Interesting thing about these animals is they have tetraploidy to octoploidy in their chromosomes. So they have this incredible amount of duplication in their chromosomes. And some people have suggested allows them an enormous amount of plasticity to evolve in a very changing environment, and might be one of the reasons that they persisted for so long. Our local sturgeon, I should say that most populations are endangered. Our local sturgeon is the white sturgeon, long-lived animal, up to 150 years in some cases. They're not, actually, they're doing quite well in our region. Although we have another sturgeon, the green sturgeon, which is highly endangered in California, a little bit less up in the Pacific Northwest. And I do want to take a moment here to talk about the plight of some other sturgeons across the world that, in spite of their poly or octoploidy, they have not been successful at navigating the changes that have been thrust upon them. And notable among these is the Chinese sturgeon, Actinopterygii sinensis. This is probably the most ancestral of the sturgeon. It's a semi-anatomous fish, meaning that it goes down towards the estuary of the Yangtze River to live out its life, and then upstream to find spawning grounds, like the sturgeons that we have here in California as well, green and white. But the combination of pollution on the river, noise from boats, and then dams has really undermined the population. And so the Three Gorges Dam went in the early part of the 21st century. They have tried to support the fishery with hatchery fish, and has not been successful. And so this is a species that's critically endangered, largely as a result of this very large phenomenon. We've been disrupted a number of populations on the river. The problem is that the Yangtze and the Pearl rivers that are comparable to the Mississippi River Basin in terms of supporting the river, and kind of industrialized, it's what the U.S. industrialized a lot of these sort of had the shaft. Another sturgeon, of course, is the beluga sturgeon, which is famous for caviar, right? My grandmother, she had high blood pressure. She was in Paris. Her doctor said, she died not young, but she died with caviar. She lived well. So anyway, she was probably single-handedly the result, or the reason that this fish is so deeply endangered, because she loved caviar. I personally have issues with it. I don't like it. And also, you don't want to eat Russian caviar. The beluga sturgeon is from the Caspian and Black Sea basins, and it's critically threatened because of overharvesting. And these are long-lived fish. They're late to mature, they're slow to grow, and so they're really vulnerable, right? And this is the case in point. However, like in California, we don't have caviar as we do here because that caviar is now. Those fish are not listed on the federal regulation. So import caviar are not allowed. So we use local caviar now. It's not such an issue. And UC Davis aquaculture has supported sturgeon aquaculture in the state, which has been a very, very successful program. Kind of cool. So the caviar you hear is reasonably safe. If you're into that sort of thing. And there's a couple of professors that we have over in animal science. There's Ann Cogner is a great professor. If you haven't met her, she loves fishes, and she has supported research into ring sturgeon, as has Andrea Drow, Andrea Schreier-Drow now, who runs the genomic variation lab, interested in genetics and fish. Andrea is a really good person to talk to. These are both really lovely women and wonderful scientists who I very much enjoy collaborating with. And if you're interested in these sorts of topics, I recommend that you meet them. Okay, the other group of Actinopterygii are the Polygonidae, the paddlefish. These are lighter fish that have smaller scales and no scutes, but they have this massive sensory rostrum out in front of them. And they're found in the Mississippi and Yankee basins. They're planktivorous fish. And they're not as long-lived, but they do get pretty massive. What they require essentially is fast-flowing riverbeds, clean gravel in order to spawn. And for that reason, they too are highly endangered. You can see here the gill rakers. Remember, the gill rakers constructed the back of the gills that allow them to handle food, and when they're densely fat, allows them to filter feed, what they use these for. And there's the large rostrum. So the large rostrum has all these sensory pores in it. Some of them are the ampullae of Lorenzi, which are like electrical detection fields, and some are like the lateral line, so they can detect water movement. And apparently they have the sensitivity to be able to detect plankton moving in the water. I don't know why, it's just to detect individual plankton like water fleas. I don't know, we got that in the book somewhere. I don't really believe that. But I do believe that plankton tends to occur in groups. So I believe that they can detect a high concentration of density of those plankton in water and be able to feed them. This is a big player. But the threats to paddle sturgeon are many. In addition to sports fishing, there they are. You can see the dam. Maybe you can see this. I mean, here's the blue is the stable population here, and then you can see around the area around the stable population, they're almost threatened or extirpated entirely. So, given what you know about the geography of this area, can anyone tell me what's going on here? Why is it everything's pretty copacetic right here in the middle of the Mississippi River, but the outside outlying regions, the population can more or less threatened or extirpated? Any ideas? Really? Farming, the farming would have the same effect on the Mississippi Basin as it would on the outlying areas. What's happened to the Mississippi Basin? It's been dammed. Every one of those states is the Missouri River, the Ohio River. All these areas have tributaries going to the Mississippi, and they can no longer. So historically, these fish most likely would have migrated up to the high end to find farming habitat. And now they're mostly confined to the Central Basin, where that sort of spawning habitat is probably really rare. I'm not sure how they're finding small opportunistic areas where they can successfully spawn, but they're pretty much limited and becoming more limited in their distribution because of damming, because of things like agricultural use that's excessive or careless, dumping of sediment wash off and nitrogen inputs into rivers like this tend to be have a really huge impact on rivers like this. It's quite clean very well. And then another sad story back to China. We just bounced back and forth from the two greatest industrial nations in the world. The Chinese paddlefish is now gone. I just found out. We were talking about this fish in the early 2000s and thinking about what the three gorges, what the impact was going to be. and they're completely extirpated. They've survived many hundreds of millions of years, and they were very common in important fishery. In the early 1980s, the Juba Dam on the Yangtze was built, and that basically cut off their spawning habitat. And you can see that this is the bypass of the dam. The population began to decrease. Once the Three Gorges Dam was built, the population was pretty much on the road. But after that, we haven't seen them. And a paper came out last year, I think, that said they're gone, they're extinct, but the IUCN has not completely updated their website. So as far as we know, they're gone. These are massive fish. 7 meters was the record for this fish. That's a whole lot of fish in the river. And that's the Yangtze. The Yangtze is a massive, massive basin. It's an enormous river. So, yeah, because they wait, and for this paper decided to put more than one. They're gone, they really are. But so much of this stuff. This is a video of this meeting. That's what I'm not going to play it. Neopterygian, and so now we're going to the Neopterygian fish, which are increasingly derived features. So number 5 of the Actinopterygii innovation is the operculum, and I should say that the previous fish that we've seen have the operculum, the gill flax. They have it, but the innovation here is the 4 interconnecting parts on the skull: the operculum, the preoperculum, the interoperculum, and the suboperculum, which create a flexible, movable structure that supports suction feeding. And suction feeding is really the key adaptation of these fishes, and then even more so in the curiosity fishes. And we just start to see it in the Neopterygian. And so just a few years ago, I believe it was 2019, just 2 years ago, this paper came out on bars. We always kind of thought bars in terms of history, because even though they have some more derived features, they still have these gaping jaws. But this really cool study went through and did an analysis of how they use suction feeding in a very subtle way. So they're not just ram feeders that go and snatch the prey and swallow it down. They have pretty sophisticated suction feeding. It just happens so quickly that it's really hard to see. And so they did slow motion photography to pull this out. And basically, what they're able to do is this whole suction feeding means that the operculum has to be adductible. Adductible means out. So the operculum can actually move out from the sides of the skull, creating negative pressure inside, which allows water to move into the mouth, and then either into the belly if they're eating, or pump water over the gills to breathe. And the way, I have to point this out, the way that they do this, that the guards do this in particular, the way that the guards do this in particular. Sorry for your home. So they have these bones here at the back of the skull. And so as their jaw opens up, the bone is pulled back, which then releases, there's a series of muscles that then release, the series of muscles then tightens up this blue bone here, which drops down, and then the combination essentially expands the size of the opercular cavity and the pharyngeal cavity like 2 or 3-fold. And so it's like, whoop, it's massive stuff. It's very exciting for this biologist to watch. And later on, I'm going to have videos, which you can watch it. So the other thing is not necessarily a new feature, but all the Neopterygians are ossified. Their skeletons have become completely calcified, and they've lost this whole cartilaginous skeleton that is effective for some of the heavier features. So, so from here on out, we'll see ossified skeletons largely. And one of the groups is the gar family, the Lepizosteiformes. These animals have a phytostomatic swim bladder, and I just talked to you about the innovation in the mouth, which is going to become more sophisticated as we go down to the evolutionary history of fishes. They have you can't see it here, it's an abbreviated heterocircle tail. So again, it's more symmetrical than the heterocircle tails that we've seen before, even though it does have like a slight, the vertebrae go up into the upper lobe of the column. And they're extinct everywhere except in North America. Extinct, not recent extinctions, just geologic extinctions. They only exist up here. They have adaptations to tolerate swampy low water conditions. And so moving right along to the next group are the bowfins. The adaptation on the bowfins that I want you to be aware of is again another extension of the jaw structure. In this case, the bowfins have the maxilla can come out all the way to the guard. This is infused to the upper jaw, to the bottom of the skull. The innovation, so that's up here. You can see into the shear. We saw that before. So in the bowfins, that maxilla is now super flexible. And so when they open their mouth, so here it is with the mouth closed, that is normal here. It drops down from this side, down forward like this, which relieves the pressure on the skull. It opens up the gate and it helps decrease the size of the mouth. You can see like this whole, fish spend a whole lot of time like worrying about their mouths. It's pretty volatile to the world. And really, the way to understand the importance of this adaptation is to think about it in terms of the medium that they're in. They're not in the air. Their environment is very strange. I mean, we've all swum, but how many of you, well, if you've gone bobbing for apples, you know what it's like, right? It's really hard. Just do it this Halloween, bob for apples. Think about how hard it is to be a fish. Because when you bob for the apple, it just moves away from you because when you close your mouth, you shoot water out. Well, fish devise this strategy of being able to move water back to the gills. And this is so important to their success, evolutionarily, that they derive a whole different series of adaptations. And the most successful fish were able to incorporate all of them in very complicated head structure, skull structure, that we will see take its fullest form in the next group, not the bowfins, but the two and the Actinopterygii. So moving along here, let's look at what we're talking about here. This is the order Actinopterygii, bowfin fish. And again, the key thing about this is the extensible maxilla. And also, I talked about scales earlier. This is the first fish. It's not a fully Symbiotian fish, but it's very, very close. It's kind of a cusp species, as it were. It has cyclic scales. So for the first time, we're seeing overlapping lightweight scales to interact with the new environment. And so here's the things I just said. It has a heterocircle tail, but again, it's symmetrical. They also have a highly vascularized swim bladder, which supports breathing, as do the guard. And this is just a bit of fish trivia. If you find a fish with a belly plate, which is this structure here, then you find a really flat structure. And they're piscivorous ambush predators, which is why the adaptations that they have are so incredibly useful. It allows them to be light, to be fast, and they tolerate very smooth being low off the water. Yes? Can you hear me with that? Yeah. Okay, turn it up a little bit. Hello? Hello? No. They can, yeah, different backup. Thank you. So I'll just talk loud and slower because you can't hear me through my mask. So that's the boat. Next up, curiosity. I actually finished my lecture ahead of schedule. I can go back and watch those videos. Any questions about what we're doing? Any questions about where we're at? Yes,
Sorry, this isn't directly related to lectures.
that's fine. Any questions? Yeah.
Assignments, as far as the, I'm seeing like a quiz two for the, like, besides the multiple or not multiple, but besides the quiz, it's, as it says, 10, 15, like, quiz two, is that, like, do we have, sorry, words, do we have a presentation assignment? What do we get?
Not for this.
Okay,
This is good.
okay, but that's second.
We should-
Yeah, it says quiz two, but it's like one of those questions for the presentation, so I'm confused. I'm trying to like take away.
No, I'm glad you told me that. Ignore that quiz too. The quiz that I gave you, I'll go fix it right away. But the quiz that I gave you, it says most of them multiple choice.
Yeah, I opened that up, so I just.
And it's still in the, it's in the, in the model. Sorry.
It's okay, I just wasn't sure if.
Yeah, thanks, man. Yeah, do that. Any other questions on anything from the class? All right, we're a little bit early then. Thanks, everyone.